Recording in progress.
Hi students, in this lecture I am going to discuss radius of curvature. Let us see what is it. Let us consider a curved path like this. Now see what happens here. If you imagine a small part, consider small part on this. So this length is very small. It is almost a single point. Now we can imagine a circle by taking this small part. So we can imagine a circle by taking this small part as a part of that circle. Okay. Now radius of that circle is called radius of curvature of the path at this point. I am repeating. First, we have taken a small length on the curved part, small length. By taking that length as a part of one circle, you just imagine, okay, one circle like this. Now radius of that circle is called radius of curvature of the path at that point. For example, let us take a small length here. Small length in the sense the separation between these 2 points almost zero. Now imagine a circle by taking now this small part. Imagine one circle by taking that small part. That means now that small part is a part of that circle. That small part is a part of that circle. Now this is radius of that circle. That means at this point, radius of curvature of the path is r dash. Like this, from point to point, radius of curvature changes. It is from point to point, radius of curvature changes. And we have to calculate that. Let us now compare that with circular motion. So when you are taking circular motion, if you consider any part on circle, if you consider any part on circle, for this one, radius will be same. For this one, radius will be same. That means for any part on this circle, radius of curvature will be same because it is a circle. But this is not a circle, it is a curved part. So from point to point, radius of curvature changes. And how to calculate that means if you see circular motion, centripetal acceleration is towards the center, which is given by v square by r, where v is now speed upon r. In this case, r is nothing but radius of circle. And here that's what calling as radius of curvature. Okay. So whenever we want to calculate radius of curvature, at that point we have to focus what is speed and what is centripetal acceleration. What is centripetal acceleration? So now taking the same thing here, let us take one example to understand this. It is find the radius of curvature of the path. Find the radius of curvature of the path of an oblique projectile at its highest point if angle of projection is theta with the horizontal and velocity of projection is v. Let us see how we solve this one. So we have to find at highest point. Given oblique projectile. Path is now parabolic. Let us take, suppose initially given angle of projection theta, that is with a horizontal, velocity is v. Suppose somewhere here, velocity vector makes an angle alpha with a horizontal and take this speed as v dash. So here you can see acceleration is g downwards, acceleration is g downwards. So we have learned that first we have to focus centripetal acceleration. So AC equal to v square by r. First we have to focus what is AC. Next we have to focus what is speed. Then we can find radius of curvature. So centripetal acceleration means it is a component of acceleration normal to velocity. See, velocity is along a tangent, right? So component of acceleration normal to velocity. That is centripetal acceleration. So here g is now downwards. Let us take components for g. One is normal to velocity. One is normal to velocity. Other one is along the tangent. Now see carefully. This is vertical. This is normal to horizontal. This is normal to velocity. So this angle becomes alpha. So here this is g cos alpha, component of acceleration normal to velocity. That is that is centripetal acceleration. Centripetal acceleration is g cos alpha. Okay. Next, if you take along the tangent, tangential acceleration is g sine alpha. So we want now only AC. So we got g cos alpha. And at this instant, speed is v dash. Okay. Or you can say how to find it in terms of v and theta. We have learned that in case of oblique projectile, horizontal component of velocity does not change because along horizontal there is no acceleration. If we are using that point, we can write v dash cos alpha. This is horizontal component that should be equal to v cos theta. So from this we get the value of v dash, that is v cos theta upon cos alpha. Okay. Now we got AC value and we got v dash value. So we are having now AC equal to v square by r. Using that result, radius of curvature is equal to it is v square by, so it is now v dash square upon AC value g cos alpha, right? And see carefully from this what we can conclude. While the particle is moving up until reaching the highest point, we can see speed decreases. So speed is decreasing and speed is minimum at a highest point. And you can see at a highest point, acceleration is only vertically down, right? At a highest point. So there is no tangential acceleration. It is only AC. So AC value how much means? It is G at a highest point. So at a highest point, AC value maximum. At a highest point, speed is minimum. So speed is minimum, AC maximum. That means at a highest point, radius of curvature is minimum. So here we can conclude that from point of projection up to maximum height, radius of curvature decreases. I am repeating, from point of projection up to maximum height, radius of curvature decreases. From there, again till reaching ground, its radius of curvature increases. So in this we have tried v cos theta by cos alpha, right? Now in our problem, they're asking at highest point. At highest point, alpha value how much? Say alpha means angle made by velocity vector with horizontal. It is 0. So cos alpha, cos 0 is 1. It is simply at a highest point. R is minimum and that value is equal to highest point means velocity v cos theta at a highest point. Square of that upon AC value g. So this is radius of curvature of the curved path at a highest point. If they ask at any instant, for example, theta value 60. Let us say when alpha equal to 37, what is R value? Then simply calculate V dash. By using this result, calculate AC value, that is G cos alpha. So AC is known because alpha is given. V dash is known because theta is given, alpha is given. So since both are known, we can find radius of curvature. Like this, we can solve questions basing on radius of curvature. Okay. Let us see next problem. The velocity and acceleration of a point-like body at an instant are as shown in the figure. Given acceleration vector and velocity vector at one instant, angle is 150, right? Find the minimum radius of curvature of trajectory of the body if acceleration vector is a constant. Students, if you observe, we can compare this with oblique projectile where acceleration equal to g, which is a constant. Okay. The only thing is in the place of g, take now a equal to 2 meter per second square. Because condition given, acceleration vector is a constant. Okay. That means if you compare with that, see what we can do here. This angle 150 means, this angle 150 means, let us make a diagram here. Angle is given 150. So I'm comparing this with oblique projectile. Oblique projectile. Angle of projection. See how much we have taken. Total value 150 given. G vertical downwards. So I'm taking in the place of G 10. It is a 2. So A equal to 2 meter per second square. And velocity given that is 8. 8 meter per second. Since total angle is 150, this is 90. Since total 150, this angle must be 60. Okay. So we have learned now, just now we have learned that at a highest point, radius of curvature is minimum. So at a highest point, AC equal to G. That means AC value 2 meter per second square. At a highest point, speed equal to, at a highest point, speed equal to, it is V cos 60. That is 4 meter per second. That means if you compare this problem with oblique projectile, it becomes very simple, right? Now remaining just calculation part. AC equal to V dash square by R. So R equal to V dash square, that is a 16. upon AC value 2. That means R value is now, it is a 4 meter. Let us cross check once. This is 8. 8 cos 16. It is 8 into 1 by 2. That is a 4. 4 meter per second. AC value 2, which is a, in the place of G, we have taken now 2 meter per second square. So R equal to V dash square, that is 16 by AC. AC is now 2. So it is now 4 meter. So like this, we can solve questions basing on radius of curvature. Okay. Let us see next problem. A smooth parabolic wire track lies in XY plane as shown. It is given that wire track is now in vertical plane. The shape of the track is given by the equation y equal to x square. A ring of mass m which can slide freely on the wire is placed at A, that is 2, 2. The wire track is rotated with a constant angular speed omega such that there is no relative slipping between the ring and the track. Find the value of omega. Students, if you observe, ring is now somewhere here. Condition is given that there is no relative slipping. That means ring is at rest with respect to the track. So since track is now rotating, ring follows, it is subtler path. Ring follows now subtler path. Means when we see from ground to frame, it is a following now subtler path. So we have to calculate now omega value. See conditions given here. Y equal to x square parabolic. It is at a location 2, 2. 2, 2 means see what we can do there. How to use this condition to find omega value. Let us take first of all. It is clear that the ring is a following now subtler path. Ring is now following subtler path. This is omega. It is, let us take this somewhere here. That ring is, suppose angle is theta. Let us take this is now location of the ring. When this wire is rotating, ring follows now subtler path. Subtler path like this. And see what we can do here. Write down the forces acting on the particle. So one is mg downwards. Second one, normal reaction. Normal reaction like this. So since motion confined to horizontal plane, motion confined to horizontal plane, there is no net force along vertical. And you can see mg is along vertical. So one component of normal reaction has to balance mg. So I can write here. This angle is theta. N cos theta. N cos theta is balancing mg. Remaining component is providing centripetal force. So N sine theta is centripetal force. Writing that net force as a mass into V square by R. But we have to calculate here omega, right? So I'm taking this as m r omega square. Okay, right. So now in this, we require what is theta value. Okay. For that, we are given that equation of the y, which is y equal to x square and coordinates of the ring 2 comma 2. So here what we can do is, if you are taking ratio for these two, tan theta equal to r omega square by g, right? See carefully. I am taking ratio. So tan theta equal to r omega square by g. Tan means it is giving us slope. So to find the slope, differentiate now this one. dy by dx is equal to, it is a 2x. Now it is at 2 comma 2. At this point, what is the slope? Take 2 here. It becomes now 4. Means tan theta is equal to 4. Right? Yes. So tan theta is equal to how much? We got 4. So tan equal to 4. That is equal to r omega square by g. Right? So omega square is equal to 4g by r. Therefore, omega equal to root of 4g by r. Okay. So in this, we should calculate what is r, radius of that circle, right? And you can see radius of that circle is nothing but x coordinate. See carefully. This is origin. So r is nothing but it is x coordinate. Okay. And what is x coordinate here? That is 2. So right here r value 2. Okay. Here r equal to 2. Therefore omega equal to 2. I here 2 times. It is root of 2g. Right. See how we are starting the problem. This ring is not slipping. Its meaning is it is a following subtler motion. Whenever any question given basing on subtler motion, first focus a free body diagram, right? Next, we have to focus which force or which forces are providing centripetal force. So here, one component of normal reaction is providing centripetal force. Or we can say same thing as resultant of normal reaction and gravitational force is providing centripetal force. So the same point we have discussed while discussing banking of roads. Even same kind of result we have discussed while discussing conical pendulum also. There we have discussed that resultant of tension and mg is providing centripetal force, or one component of tension is providing centripetal force. Okay. And to find that slope, we are given path equation and coordinates of that ring. So like this, we can solve problems. Okay. Let us take next one. See the question given. A rigid and thin semicircular Y-frame of radius r is hinged at O as shown. This is now semicircular wire, rigid and thin. It can rotate in its own vertical plane. Condition is it can rotate in its own vertical plane. A smooth peg P starts from O, moves horizontally with a constant speed V0, lifting the frame upwards as shown in the figure. Find the angular velocity of the frame when its diameter makes an angle 60 with the vertical. Let us make a diagram first. Given it makes angle 60 with the vertical. And what we have to find? We have to find omega value. So with vertical, let us take it is now moving horizontally. We have take one we have take semicircular wire. It is like this. At one point of time, its diameter is making an angle 60 with vertical. Or let us take it as theta, where theta equal to 60. And we can see this is now location of the peg, which is moving horizontally with a velocity v naught, right? So we have to calculate omega value. So first focus how to start the problem. So we are given velocity v naught and given speed is a constant moving horizontally, or you can say velocity constant because direction not changing, speed also not changing. And we are knowing that definition of velocity, rate of change of displacement or rate of change of position vector with respect to time. Let us take this a horizontal as x-axis. So here only x coordinate is changing because it is moving only horizontal. So only x coordinate is changing. Let us consider now what is the x coordinate here. If this is a theta, remaining is now 90 minus theta. This length, suppose this is A and this is B and this is C. AB length is 2r. AC becomes x coordinate is nothing but length of AC. That x coordinate is now 2r cos 90 minus theta. That is now sine theta. And we are knowing that velocity means rate of change of position vector with respect to time. So differentiate this dx by dt, that is equal to v naught, which is equal to 2r derivative of a sine theta. It is a cos theta into d theta by dt. Since this d theta by dt is now angular velocity, right? And we have to find this when theta equal to 60. So next step, v naught equal to 2r cos 60 1 by 2 into omega. So 2 gets cancelled. Remaining is now omega. Omega is equal to v naught by r. That is our answer. So here key point is that velocity is a constant. So immediately we are focusing what is its position coordinate and derivative of that. So I hope you got a clarity.